Good evening, friends. Welcome to the teleconferencing session of School of Agriculture. Today we will be covering the Dairy Technology program. If you recall, last time we covered the block 1 of the dairy equipment and utilities, that is course number 2. So today we will be covering the part 2 of this course. You know, this course has 5 blocks. So the first block has been already covered, and now we will be covering the remaining 4 blocks. The 4 blocks are refrigeration system, steam generation and boilers, electrical engineering and safety devices, water supply and dairy effluent system. I will try to cover all these blocks, but mainly I will be focusing on the refrigeration system. Now, the refrigeration system is the main part of the course, because refrigeration plays an important role in the system. Under this refrigeration system, it has 4 units. The first unit is basic principle and components of refrigeration system. Next unit is different cooling systems for milk and milk products. Third unit is cold storage and insulation, and fourth is maintenance and repair of commercial refrigeration system. Now the objectives of this is, we'll come to know what is refrigeration, explain the basic principles and working of vapor compression refrigeration machine, describe the working function of different components of refrigerating machine, and what are the properties of refrigerants, and what is the selection procedure. These are the objectives of the unit 1. Now what is refrigeration? Refrigeration is production of cold in a space. It brings and maintain the temperature of the enclosed space below that of its surrounding. How does it do? It extracts energy from the space, retards the natural flow of heat from surrounding to the space by insulation, and it is an important service requirement. What are the important components of a refrigeration system? The important components are refrigerant, compressor, condenser, receiver, expansion device, and evaporator are there. Then what are the principles, or what is the principle of this is, the main thing is refrigerant is the working substance. Then compressor, it compresses the refrigerant vapors at low pressure and temperature to high pressure and temperature. The third important component is condenser, where the vapors are condensed into the liquid. Expansion device, it reduces the pressure and throttles the vapors. The evaporator is the heart of the refrigeration unit, where the low temperature liquid evaporates. It absorbs the heat and produces the cold, and then the vapors are again compressed into the thing. You see the diagram. This is the diagram. This is the compressor, where the vapors are compressed. Then they will go to the high pressure and high temperature vapors. They are compressed, and then this is the condenser, where the vapors are transformed into the liquid. Then this is the receiver, where we keep the vapors. Then from the expansion device, where the pressure is reduced, they come to the evaporator, and in the evaporator, the evaporation of the vapors takes place. During the evaporation, they take the heat from the system, that part becomes the colder, and the vapors move further. So this cycle, that is from compressor to condenser and then to the expansion device and then to the evaporator keeps on going. And we divide the complete system into two sides, low pressure side and second is the high pressure side is there. The vapors are on high pressure side, that is known as the high pressure side. After expansion device and the evaporator, they are at the low pressure devices there. There are different types of systems are there, but the most common is the vapor compression refrigeration system. This is showing the more diagrammatical way. This is the compressor is there. This is the way we show the compressor. So from the compressor, the vapors are moving. They will come to the condenser. The high pressure vapors are condensed, and in the condenser they are changed into the liquid. Then the receiver where we store the things. Then through the expansion device they will come to the evaporator. This is where the vapors, they will absorb the heat from the place where we want to keep the cold and they will go to the condenser. If you recall your fridge, this is the place where you can see the coils where the actually refrigeration effect takes place. This is the operating coils and this is a type of system we show it. Now how do we say there are different units are there. What is 1 ton of refrigeration? It is to show the capacity of refrigeration machine. Like 1 ton we say it converts 1 ton of water at 0 degree centigrade into ice at 0 degree centigrade in 24 hours. That is known as the capacity of the refrigeration. You must have heard when we say the capacity of our AC unit is 1 ton. So this is to say that this unit can convert 1 ton of water at 0 degree centigrade into ice at 0 degree centigrade in 24 hours. In terms of extraction of heat, it is around 50 kilocalories per minute. The second term which is used is COP, coefficient of performance. This is the ratio of heat extraction to power consumption. We know that this is basically involves heat extraction, and for heat extracting we need some power consumption takes place. So this is the ratio. Now higher the COP, better is the performance. So these are the principles of the refrigeration. So with the diagram I have explained that what is the refrigeration is there. Now we mentioned that there are the 4 different parts of the refrigeration. First is the compressor. Now see what is the compressor. Compressor is the different types of compressor and there are different ways of classification. If you see the unit, it has been explained very well. This diagram shows you the reciprocating compressor. Now you see, this is the suction port, then there is a discharge port is there, then there is a suction valve is there, and there is a discharge valve is there. This is the cylinder and this is the crankshaft is there, and this is what we call the piston is there. The vapors are sucked and then they are the compressed is there. The same like in our scooter piston or our car piston. So same arrangement is there. The compressor, we have a suction stroke, we have a discharge stroke is there. And this is the piston. So the important parts of a compressor should be known. There is suction valve, discharge valve, suction port, then the piston, crankshaft. These are is there. So when the vapors will be sucked through the suction valve and they will be discharged through the discharge valve is there. So this is the compressing part is there. Then the condenser. If you recall, the condenser is the unit where the vapors are transformed into the liquid. There are three types of the condensers. The first one is the air-cooled condenser. These are the pipes where the liquid, the refrigerant flows, and these are the plate type fins are there. This is air-cooled is there. When the air passes through them, it will cool the refrigerant and it will be converted into the liquid. If you recall your fridge, on the back side you may find some coils. In the current fridge, this is placed in the side doors on the side. But if you see some old fridge, some black type of fins are available and some pipes are there. So these are the things. Those are known as air-cooled condensers. So in your house, if you see, the air-cooled condenser could be seen on the back side of the fridge. The black type of fins type of things are there, and then there are certain coils through which the refrigerant flows into the things. Then next is the water-cooled condenser. Now what happens in water-cooled condensers, instead of air, the water is flowing through the system and it is cooling the refrigerant. So you can see refrigerant vapors and the liquid refrigerant is coming out, and this is the flow of the water. Cooling water is flowing inside and then the hot water is flowing outside. That is, this water has chilled the things, the vapors have been converted into the liquid, refrigerant liquid, and then the condensing water is going outlet. So this is the cooling water inlet, the condensing water outlet is there, the refrigerant vapors inlet and liquid refrigerant outlet. So this is known as the water cooled condenser is there. And the third type is evaporator cooler is there. In this evaporator condenser, what is this? These are the refrigerant coils, and then the water is sprayed onto the top. Sometimes when you see the ice factory or where the cooling process is there, you must be seeing that some water is falling, and then this is the evaporative cooling of the thing is there. Because what is happening is, because of this evaporation, the refrigerant vapors are changed into the liquid refrigerants are there. These water, chilled water, then this is again pumped and then it is again thrown. So this is a sum where we collect the water, condensing water. Through pump it will go and it will be sprayed onto the top. This is the vapors are going inside, then the liquid refrigerant is going. So this is the place to maintain the level of the thing is there. This is evaporation, because this is a type of evaporation where the cooling takes place because of the evaporation. Because this cooling water, they take the heat once they evaporate, and they take the rate of heat of evaporation from these coils, and the vapors are changed into the liquid refrigerant. So these are known as the evaporated condenser. Then the next important unit is expansion device. In expansion device, there are three types of expansion devices are there. The first one is the capillary tube is there. If you recall the diagram, the first diagram we mentioned, that this is the expansion device. Its one end is towards the receiver and the second end is towards the evaporator. And in this also, capillary device is placed here. Its one end is to the vapor refrigerant or out is there, and this is the liquid refrigerant from the condenser. In between, expansion device is placed. So this is the capillary type of expansion device is there. Now expansion device, it mainly converts from the high pressure refrigerant to the low pressure. So when this from the condenser, the high pressure liquid is coming through strainer. When this capillary is flowing, with the passage of the time, with the orifice, what happens? This is changed into the low pressure liquid, and which enters to the evaporator is there. So this is a low pressure liquid which enters the evaporator is there. Now depending upon the size of the orifice and the length of the capillary tube, we can change the thing. If the length is more and the orifice is small, the pressure drop is more. If it is otherwise, the reverse will take place. Now this is the simplest mechanism of expansion device. The next one is thermostat expansion valve. This is a type of thermostat expansion valve is there. What happens? This is a valve. This is the valve seat is there. This is a diaphragm, and this is a capillary tube is there. This is the evaporator is there. The refrigerant comes from this place to the evaporator, and this is the refrigerant out is there. And this is the refrigerant in from the condenser. So the condenser, all the refrigerant will flow from here, but the further flow to the evaporator is controlled through this expansion valve. This is the seat. You can see this is the valve seat, and this is the valve. Now depending upon the flow is controlled, whether we are allowing the less refrigerant to go into this side, or we are allowing the more refrigerant to the. This depends upon this bulb, the sensing bulb. This sensing bulb through the capillary, it controls the diaphragm. Now if the evaporation is more, so then it will allow the more refrigerant to flow inside. If evaporation is less, then this will allow the less refrigerant to flow inside. So all the refrigerant will come this side, but depending upon the temperature or whatever is the outlet evaporator temperature is there, we try to control through this expansion valve. So this expansion valve does the two purposes. It reduces the pressure also, and simultaneously it controls the temperature also. This is the advantage of this type of expansion valve. Then we have a low side float valve also. This also serves the two purposes. It is an expansion valve, and as well as it is also to control the temperature also. So these are the two types of the expansion valves there. Then we come to the fourth important component, that is known as the dry expansion evaporator. As we mentioned, evaporator are two types. One is dry expansion evaporator, and second is flooded type of evaporator is there. So dry expansion evaporator is this type, the liquid refrigerant. When it is basically the refrigerant here is more of vapors type, so it is known as the dry expansion evaporator is there. And when it is liquid refrigerant, it contains some of the vapors in vapors forms also, so it is known as the dry expansion evaporator. And if you see the flooded type of thing is there, the refrigerant present is in the liquid type is there. So this is the float, and this is the refrigerant. So it is a mode of flooded type is there. Normally when the capacity is less, we use the dry expansion evaporator, and when the capacity is more, we use a flooded type of evaporator is there. The evaporation, the cooling effect will be more in the flooded evaporator, and in the dry expansion type, the cooling effect will be less, will be there. Then we come to the refrigerants. Because this refrigerant is the main thing which runs in the system and controls the cooling effect. What type of should the characteristics should be there of the refrigerant? The first thing is the freezing point must be lower. Then the latent heat of its vaporization be high. Its density should be high, volume should be small, the condensing pressure is low, and it should be able to operate temperature and pressure without decomposing. What we call them as the thermal properties of the refrigerant. Then there are certain generic properties, like it should be non-flammable and non-explosive, it should be non-corrosive, it should be non-toxic and non-injurious, there should be no harmful effect on taste and the food quality, it should have low initial cost and economical to maintain. These are certain properties of refrigerant. The common refrigerants which are used is ammonia, then phenol 12, refrigerant 22, 11, 114. But for in the dairy industry, ammonia is used. It is favorable because of the thermodynamic and physical properties. It has high heat carrying capacity. Some of the disadvantages are it is toxic and it could be irritating also. It is flammable and sometimes it gives bad taste to the food also. But because of the other advantages, which are thermal properties, it is still preferred. But in our household and other things, we use the hydrocarbons are like freon, refrigerant 22. These type of refrigerants are used. The next unit is about the cooling system. And this, the first thing comes, what is the purpose of cooling system? The cooling system required because it increases the storage life of milk and milk products. You remember that milk is a perishable commodity. Once it is produced, it is very sterile. We have to increase the storage life of milk and milk products so that when it reaches the consumers, they are safe and they are in good quality. The milk is produced at form. It should be chilled as immediately as possible. It will extend the shelf life. The storage of milk and milk products should be also done at the low temperature. And then there are certain processing parameters, like when we want to make ice cream, we have to chill it. Once you want to make butter, we have to lower down the temperature of the cream. So these are the processing and manufacturing requirements where the cooling is to be done. So these are the importance of the cooling the milk and milk products. Basically, one of the objectives is to increase the storage life of milk and milk products, because you know at the lower temperature the microorganisms cannot grow, and once we store the milk and milk products at low temperature, the shelf life increases to a large extent. And then for the processing is there. Then what type of systems are there? So we'll take one by one. First, at the form level, what we call them as the form milk coolers. There are two types of. First is the can cooling and then the bulk milk cooling. Can cooling is ice chambered with non-insulated cans, then milk cans in chilled water, milk cans in chilled water with separate refrigeration unit, then immersion cooling, surface cooler, and last the bulk milk cooler is there. I will explain one by one all of these. The diagram which you are seeing is of the cans in chilled water with insulated tank is there. In the village or at the collection center, we prepare a tank with insulated. Insulated means so that the temperature of the water will be same. That is a double, so that this is insulated is there, and we put the chilled water is there. What does this insulation does? Insulation does that the outside temperature will not affect the temperature of the inside, because this water is at low temperature, outside temperature is high, so insulation sees that the high temperature doesn't affect the inside temperature of the tank is there. And we put the milk cans. It can be of capacity of 2, 4, 6 or 8 depending upon the cooling, the capacity of the collection center, and then you can chill the milk cans into this is there. So this is that you take the chilled water, put it into this, we put the milk cans, the level of chilled water should be minimum up to the milk cans level, and this is how we chill them. The next is, what is the additional thing is there, that this is with the refrigeration.
Have you said Vishakhapatnam online?
Yes, please. Vishakhapatnam.
सर आफ्टर कूलिंग हम कितने घंटे का मैक्सिमम प्रिजर्वेशन कर सकते हैं सर?
After, that depends upon your initial quality of milk. Normally, when you take the milk, if the initial quality is very good, you can increase the shelf life up to 2 days or even 3 days. But if your initial microbial load is very poor, then the shelf life will be say 6 to 7 hours or 8 hours is there. But if the initial quality is very good, you can extend the milk life up to 2 days or 3 days also. And then the important thing is how you are maintaining the cold chain. If you have chilled the milk, and if throughout the chilled you have the cold chain is being maintained, then the life could be even more also. 3 days it can go without affecting the milk quality. But if it is poor, the milk quality is poor, and you are not able to maintain the cold chain, then it could be further, I would say the shelf life could be only for 4 to 5 hours or 6 hours is there. I hope this answers, or you want some more information on the subject? Otherwise we continuing with so this is a type of condensing unit, that is, we attach a refrigeration unit to this. The water is continuously chilled, and with the agitator we are moving the water so that it continuously, the temperature doesn't rise high, and we can chill the thing. Here the cost will be more, but then the advantage is that you will be able to increase the shelf of the milk. I think my friend who has asked the question, he can, in the first one we cannot extend the shelf life to very high. Say that will be 6 to 8 hours, while in this case it could be overnight. And if the quality of the milk is more, it can be further increased to 2 days, because continuously we are able to maintain the low temperature. This is the difference. Here cost of chilling will be high because the complete refrigeration unit is attached here. The next is the can immersion cooler. In this is the can, this is the immersion unit, where these are the refrigeration coils are there, and it is a type of agitator is also there, and where this is the complete refrigeration unit, where the flow of this works as an evaporator come agitator. So then this will be chilling the things inside the can. The milk is chilled, and then the chilling effect is visible. That is, the can immersion chiller is there, and we can chill the milk to the low degree centigrade, and this is, we can put it in other can, and that way we can store the milk is there. This is a type of surface cooler where the milk is there, and through a surface cooler, through a refrigeration unit, the chilled water could be flowing into this refrigeration, and we can chill the milk into the surface cooler is there. Normally at the form level, this is the bulk milk cooler. When the bulk milk cooler mean the milk in the bulk quantity, either at the collection center, if the milk is of the more size, the quantity is more, or at the chilling center, or at the farm, if the milk collection is in 1000 liters or 2000 liters, then we use this bulk milk chiller. It is a type of a double jet vessel. where inside we put the milk. Then there is a space where the chilled water can be put and ice can be put, or we can be circulated into this. Now here the chilled water will be also there, and the cooling coils will be also there. And then the outer vessel insulation is there, and then the outer vessel is there. These are the different diagrams. If you see your unit, this has been depicted with the numbers, it is there. This is how the bulk milk cooler looks like this. There is a the complete compressing unit, all those parts are here, and then these are the coils, the operation coils are there, and we can chill the milk up to the low level. So this is the bulk milk cooler is there. Normally for the dairy, we try to have a chilled water supply system. When we have chilled water supply system, this means we make the chilled water, and this chilled water is used for doing all the chilling purposes. That is in pasteurization, or in the chilling of the milk, or in the storage tank if the chilling is to be done. So we use the chilled water. It is an indirect method of cooling, but there are a lot of advantages are there, because we can use the network of cooling coils, and then the flooded type of operator is there, then agitator is there. So these are the advantages. Normally use the chilled water supply system. We do not use the direct system, because direct system is more expensive, and if the power is not there, then the system will not work. Once we create a chilled water, then that chilled water could be used for the many other purposes, and even if the power is not there, that system could take places there. System could take care of the temperature rise into the system. So we use the chilled water system is there. This is the diagram to show you the chilled water system there. These are the cooling coils are there. This is the chilled water is there, and some refrigeration cycle there. So you can see the agitator is there, and this is the chilled water supply. If you want to make up the water, the more water could be there. So warm water after circulation will come here. These are cooling coils. This is the refrigeration going to the compressor. Refrigeration up from the float wall. This is the like operator coils are there. So this is there. So what does this coils, operation coils, will cool the chilled water, will make the chilled water, and then this chilled water is supplied to the pasteurizer, to any other unit wherever the work is required. And this is the makeup water. If you want to put up more water, it could be there. Then we come to the refrigerated storage. This refrigerated storage mean like household refrigerator, deep freezer, walk-in cooler, display case, and cold storage. These are the certain examples of this. We can use household refrigerator. You must have in a small unit we can use for the storing the milk and products, and deep freezer is there for the larger products. Normally the cold storage is used in the dairy industry for storing the milk and milk products in the dairy plant itself. But at the small level, deep freezer or walk-in cooler, these are the type of things are there. So you can see the refrigeration unit is there. This is the coils, operator coils are there, where the main chilling will take place. So if you have the fridge, you can see that where the main chilling will take place, and this only the cooling effect in all the sections of the refrigeration take place. Then this is the deep freezer is there. You can see this is type of insulated box is there. Then cooling coils are there, and through this the cooling will take place. Normally the cold storage is of this type. You can see these are the products racks where the dairy products are there. This is a insulated door. This is temperature sensing device. This is the cooling coils. Here the blower is there which will be blowing the chilled air to the cold storage and the cooling will be taking place. This is the insulated cold room is there. You can see the compressor, then low pressure, high pressure cutout is there, then the condensing unit is there, then the solenoid valve, and then this is the expansion valve is there. So this is the cold storage. It is basically that, so you can see this is a type of the cooling effect which will take place, and to the blower the chilled air is blown and the cold products are created. I would say we chill the milk and milk products is there. So this is the typical diagram of the cold storage is there. The basic components are same in this also. We have a compressor, we have a condenser, we have a expansion valve, and this is the cooling coil or operation coils are there. Now the important components, as I mentioned, is the door. The operator is normally flooded type, then the blower is there, then compressor, then normally the compressor is reciprocating type, ammonia type compressor is used. Now there are different types of controls are there to control the things. What is you must have seen this in the diagram, that this is the low pressure control, LP, HP cutout are there. Now what are these cutout? So this is the low pressure cutout. Sometimes what happens when the suction is not complete, the pressure is not complete, then if you try to compress the compressor, the compressor has to do the work, this can spoil the system. So what we do is we put a low pressure cutout. So this is always kept on the low pressure line, on the suction line. So if there is a less pressure, then this cutout will cut off the supply to the compressor. So this is the low pressure cutout is there, supply line is there, and then there is a discharge side is there. So if the pressure, suction pressure is less, then this switch out will sense the thing and will cut off the supply. Similarly, we have a high pressure. Sometimes when the condenser is not able to do its job very properly, so what happens? The pressure will be rising. So when the pressure is high, so we put a cutoff on the discharge line. So this cutoff point is there, and it will cut off the supply to the compressor. So this is known as the high pressure the compressor. The cutoff point is there. HP cutout is there. So that is on the low pressure side, and this is on the high pressure side is there. And some third type is temperature controller, which is based on the temperature setup. So if the temperature is more, then this will be sensing the things and it will be doing. If the temperature is less, then the flow of refrigerant will be more, and then the cooling effect will be more. So this is that type of devices which we call them the control devices are there. When we design the cold storage, what type of consideration we keep into the mind? So we keep into the type of the product. Then on the type of the product we see what is the load before freezing, what is the freezing load, and what is the deep freezing load is there. So heat conducted through walls, roof, laborers, that infiltrate air, then heat ducts. So these, based on these considerations, would design the cold storage and the refrigeration capacity of the thing is there. Normally we use the insulating material. It is important to see that their properties. Normally the insulating materials used are cork, thermocol, copac, then insulating wool. These are the common insulating material. This is a type of diagram to show that how the wall insulation is there. We put the cork board inside is there. Then on both sides the waterproof cement plaster is made. This is the brick wall, and then inside is the insulation, and both sides the cement plaster has been made is there. This is again to show you that we have a metal sheet refrigeration wall, the glass wall insulation is there. Then the maintenance and repair of refrigeration plant, of compressor, of condenser, operator, and common problem and remedies. So this unit covers this is there. So we should take care of all these aspects are there. I think friends will not be able to cover the other units, so I will only try to cover this refrigeration part into this. Now I'll try to control the recapitulate the things that what we studied. We studied the important components of the refrigeration. The important components are the refrigerant itself, then the compressor, condenser, expansion device, and the operation coils is there. The condenser condenses the high pressure vapors into the liquid. Then the expansion device changes from the high pressure to the low pressure liquid. The evaporator coils converts the liquid into the vapors where the main cooling effects take place, and then the compressor compresses the vapors into the high pressure and high temperature, and then it goes to the thing. So this is the cycle of the what we call the refrigeration cycle is there, and these are when we show it to the diagrammatically, it is a compressor is there, the condenser is there. Then we have also the different type of expansion devices we mentioned. It could be capillary device, then we have the thermostatic expansion valve, then the low side float valve is there. Then the important control devices are like low pressure cutout, high pressure cutout is there. Then we have the insulating material, that is thermostatic, that is a cork is there, insulating wool is there. Then we also studied different type of cooling system. We had the fan cooler, we had the bulk